Okay, so to start on the graphing method, the first thing you're going to do is plot remember y equals mx plus b. The b is where we're going to begin. So we are going to put our first dot at -5 on the y-axis. On the y-axis. We always start on the y-axis. So I'm going to put a dot at -5. And then the slope of this line, the m, is -1. That's the number in front of the x. And if we want to do the slope as rise over run, we would put a 1 under it. So it's -1 over 1. And that's going to be our rise over our run. So I'm going to go back to my -5 on the y-axis. And remember, I need a negative slope. So in your mind, I want you to visualize something that looks like that, a negative slope. But I want to make it perfect. I don't want to do just draw a line. I need to make sure it's exactly -1 over 1. So I'm going to start at -5. I'm going to count up 1, left 1, up 1, left 1, up 1, left 1, and keep putting dots, up 1, left 1. I could also go down 1, right 1, down 1, right 1. All that is going to give me a -1 over 1 slope. Okay, so now we've graphed that first equation. The second equation, we're going to start at 3 on the y-axis. Okay, because that's our y-intercept. So make sure it's +3. And then the slope of this one right here is 3. If I were to turn that into a fraction, it would be 3 over 1. The rise over the run. So that means we can either go up 3, 1, 2, 3, and over 1, or we can go down 3 and left 1. And if you're confused on how I got that, you know that +3 is the slope, right? So you know what a positive slope looks like. It's going up on the right. So using the 3 over 1, that's how I know I'm going to either go up and right or down and left. So if I continue going down 3, left 1, down 3, left 1, I'm going to hit that other line right there. I'm going to just do it one more time. Down 1, 2, 3, over left 1. And then I'm going to connect the dots. And I have my two equations graphed. And the solution down here is where the lines cross. So where did those two lines cross? At what ordered pair? Remember, an ordered pair is always x, comma, y. And the x value, it's hitting the x-axis at -2, and it's hitting the y-axis at -3. And that is my answer, -2, comma, -3. That's the solution to the ordered pair. And for number 2, the substitution method, if x is equal to y minus 1, then wherever I see x, I can take it out and replace it with y minus 1. So I'm going to rewrite this equation here, but instead of the x, I'm going to write y minus 1 because they're equal. I'm allowed to replace it. So what is left in that equation? The rest of the equation is plus 2y equals 8. And now I'm just going to solve this equation like we solve normal equations. So I'm going to combine my like terms. 1y plus 2y is 3y. I'm going to bring down the -1, bring down the 8, and I'm going to do the opposite. The inverse of -1 is a +1. So the opposite of subtracting 1 is adding 1. And that creates a 0 pair here. And I'm left with 3y equals 9. The inverse of multiplying by 3 is dividing by 3. So I'm going to divide both sides by 3, and y equals 9 divided by 3 is 3. As soon as you know that y equals 3, I want you to write it right there because you're halfway done finding the answer to the solution to this system. Okay, now that I know that y equals 3, wherever I see y, I can plug in this 3 because they're equal. So I'm going to go back up to this equation up here, x equals y minus 1. And wherever I see the y, What can I plug in? I can plug in 3 because they're equal to each other, so I'm allowed to do that. So instead of y minus 1, I'm going to write 3 minus 1. And 3 minus 1 is 2. And now that you know x equals 2, you put it right there and you are done. The solution is 2, 3. Hope that helped.